Well, hi everyone, and welcome to Transitioning from ROBOTC to VEX Coding Studio, Part 4. My name is Jesse Flatt. I'll be the presenter for this session. Today we are going to talk about transitioning from ROBOTC Graphical to Modkit Blocks, and then show some additional resources that are out there to help you. As a reminder, um, a lot of the material that I use comes from the VEX EDR STEM Labs website. There is a section inside of there devoted to transitioning from RobotC to VEX Coding Studio. And so a lot of the pictures that I show are on there along with descriptions that you can reference anytime. So feel free to check that out. It's a very helpful reference along with the other resources on that site. Now, whenever we are talking about programming using a graphical language inside of VEX Coding Studio, we are talking about using the Modkit block language. This allows you to get started programming by dragging and dropping out blocks. So if you've programmed in languages like Scratch or Blockly before, uh, the the user interface, the mechanics of how this language snaps together and works will be very familiar to you. Now, that said, there are some significant differences if what you are used to is programming inside of RobotC Graphical. RobotC Graphical is what is considered a sequential language where your program starts at the top and then works its way down. And there's things like loops and if else that change the program flow or change the program execution. But generally speaking, it starts at the top and works its way down. Well, Modkit will feel familiar because it is the blocks you can drag and drop. It keeps you from making typing mistakes and things like that. But it is not just a sequential language. Sometimes commands are run sequentially, we'll see that. But at its core, it is what is considered an event-based programming language. With an event-based programming language, instead of the premise being the program flow starts at the top and then works its way down, the premise is that code starts running whenever an event happens. So an event on a computer can be lots of different things. It can be user input, like clicking on a mouse or typing on a keyboard. On a robot, it can be input from sensors, trigger an event to happen. And then within Modkit, a very popular one is just sending messages within the program itself. And what I mean by that is something called a broadcast. So you are able to control the flow of your program execution within Modkit by triggering events. And how you trigger those events is using what are called broadcast commands, and we'll see that soon. But again, a fundamental way to think about this language is that it's driven by events. And so that will affect how you structure your code. It affects how you read the code. You can't just go from the top to the bottom. All right, so let me actually show VEX Coding Studio. So I have VEX Coding Studio right now inside of Modkit block mode. And what you'll see is that it's a very nice, bright, attractive interface. And what you do is you grab blocks and you drag and drop them into your program. All right. So every program that you write for Modkit will have at least one of these when started control blocks. So started is the name of an event. It's a name of an event that exists inside of every program. And it indicates whenever your program is started, hence the name. So when your program is started, do some stuff. Now, whatever that stuff is, we can put in between the brackets of the when started control block. Now, uh, what I mentioned was something about controlling the flow of the program execution, and a big part of that being messages. So if I drag and drop out a broadcast and wait block, what that does is it says, hey, send program flow to this other event, trigger this other event to happen, and execute the code there, have the code execute there before coming back. Now, right now, there's no other events. I haven't created one. I get to name my event. I get to structure it, put whatever code I want associated with it, that kind of thing. So if I drag and drop a broadcast and wait block in, and I have no existing events, then I'll need to make one by clicking New, and I can type in and the name for an event. Let's call this demo event. And what you'll see is that it automatically gets fully capitalized. And then I can drag out another when block. And instead of choosing started, I can choose demo event. Okay. And then let's say inside of demo event, I wanted to print some stuff to the screen. Wait for a little while, print some different stuff out. Okay. So I can put whatever code I want to inside of my event. And then the way to parse this program, the way to think about this program is my program flow, the program execution starts at when started. When my robot reaches a broadcast and wait, it jumps its program flow, its execution to that event. It runs the code inside of there, however long it takes, and then it returns the program execution back to the when control block. There's also a broadcast instead of broadcast and wait. If you do broadcast, that says, hey, start this event, but also keep doing whatever you were doing inside of the when started block or any other event. Okay. Um, and so events allow you to structure your code, so you can set aside code that you can call or reuse multiple times. In that way, it is similar to a function, but this is not a function or a subroutine. Okay, functions and subroutines, you can pass data into them, you can pass variables into them, and you can have data return out. You can have it return a value out of a function. An event um, allows you to associate code with it, like we have here. It allows that code to execute. But if you're going to modify any kind of data, then you'll need to do so using just global variables. Okay, so um, this is just a very short and kind of simple example to show, hopefully, how program flow is a little bit different inside of Modkit than it was inside of ROBOTC Graphical. All right. But as usual, I do have some sample code here. Shows you how things were done in ROBOTC Graphical, and now at least one way that you can accomplish it inside of ROBOTC Text, or sorry, Modkit Blocks. There are multiple ways that you can program these behaviors. Keep that in mind. There's more than one way, but we're just showing you one of those ways. So inside of ROBOTC Graphical, if I wanted to make the robot move forward and backward, I had a forward command for moving the robot forward. I could specify the number, the type of units, and the motor power level. Same goes for backward, and then a wait between those two commands. With Modkit, um, we have some different commands that we are using. Here, the first set of commands that you see within the when started control block is a couple of set velocity control blocks. The set velocity control blocks set the default motor speed for any subsequent movement until you change it, or for the rest of the program. So notice that inside ROBOTC Graphical, even though the forward and backward commands, even though we wanted both of them to run at 75, we specified that twice. Well, inside of Modkit, you can specify it once at the top of your program, and then it knows to just keep using those values over and over again. And that's nice because if you do want to change the speed for your entire program, let's say you wanted to slow the whole thing down to 40, you just have to change that up at the top of your program, and it ripples throughout. The next set of commands are the start, rotate, for commands. If you tuned in for some of the C++ webinars, the commands here work in a very similar way. The start, rotate, for commands, as their name implies, starts a motor spinning toward the desired duration. So here that's 2 revolutions. So in Robot C, we said 2 rotations. Here we say 2 revolutions. But the start, rotate, for commands do not hold program flow. They allow program flow or program execution to pass through them quickly. So in order to actually allow the behavior, the robot behavior of moving forward to complete, we have a wait until command, which is waiting until the left motor is done and the right motor is done. Okay, so the start, rotate, for commands start the motor spinning. The wait until command, whenever you have the condition of left motor is done and right motor is done, allow those motors to keep spinning until it's actually reached the target destination. Notice that for my robot to move forward, I did turn on the right motor separately with right motor dot start rotate for, and the left motor separately, left motor dot start rotate for. Okay, so we are independently controlling both of those motors, whereas with the forward command, it was kind of all abstracted behind that. Here you do choose each motor to create the robot behavior. The wait command is pretty much identical. In ROBOTC Graphical, we had wait 2 seconds, and in Modkit, we have wait 2 seconds. And then moving backward pretty much mirrors moving forward. We have a left motor dot start rotate for, a right motor dot start rotate for, and then another one of those wait until commands. So that's going to hold the program flow again until the motors are done spinning. Notice it doesn't matter if you're moving forward or backward, it's just waiting for the movement to finish. So that's nice that the condition stays the same pretty much every time. The only difference between a forward movement and a backward movement is that with forward, we gave it a positive number of revolutions 2. With backward, we gave it a negative number of revolutions, -2. All right, turning. Turning is incredibly similar to forward and backward. With ROBOTC Graphical, there were dedicated turn right and turn left commands. With Modkit, we are using separate start, rotate, for commands. And then the big difference here to notice is that one motor is given a positive duration to spin of 2 revolutions, while the other motor is given a negative duration. So these are tank turns or point turns where one side of the robot is moving forward and one side of the robot is moving backward. Right? But to create a turn, we just have one moving forward and one backward. And how we do that is we give one motor a positive duration and the other motor a negative duration. Arm control. Inside of Robot C, we would often use the move motor target command. Now, there are other commands inside of RobotC that you could use. The benefit to the move motor target command is that similar to the start rotate for, it didn't block and hold program flow until that target number of encoder counts or that target number of rotations was reached. Now, why that's important on an arm or on a claw is because you are using a finite range of motion. Okay, uh, on an arm and on a claw, very rarely can you spin continuously 360 degrees over and over and over again. Usually, you will hit some kind of mechanical limit. So, if you tell a motor to, hey, go to this position, but it physically can't get there because it hits a mechanical limit, what you can do if you write code certain ways is that you can lock your program up. The robot keeps on trying to reach that position. It never moves further on in the program. It seems like it gets stuck. And in a really bad scenario, maybe it damages some of the components of your robot. So here we are using the move motor target command. And then immediately after it is a wait for 5 seconds. So what's happening is it's going to start the motor moving towards the target. And then if it doesn't reach it within 5 seconds, we stop the motor anyways. And so if we had more code after that, if we wanted to make sure we weren't damaging the robot, that's a good way to do so by timing out the command, um, even if it stalls out, even if it hits a mechanical limit. We can take a similar approach in Modkit. Inside of Modkit, we can set the stopping mode of the arm to hold. That's really great because what that mode is, by setting the arm motor set stopping to hold, it will continue to draw power to hold the arm motor at a certain position. So that makes it a lot easier to drive with. That you don't have, your robot's arm constantly falling while you're holding a game object or something like that. So setting that is a really nice feature. And then the next line is set timeout, and then you can specify a duration. So inside of VEX Coding Studio, they try to take advantage of this, right from the get-go inside of Modkits by allowing this set timeout command. And then the next command is rotate to. Okay, so we're asking to rotate a certain number of degrees, 630. And if it's unable to do so within 5 seconds, then it times out, it moves on in the program. Again, keeping you from getting stuck here, keeping you from damaging your robot. All right. Remote control commands inside of RobotC. You had a tank control command. You also had an arcade control command. You had to embed those inside of an infinite loop. So here in my RobotC program, I can see the repeat forever loop being used. So that's going to repeat my tank control command. And what it allowed me to do is specify a joystick channel to assign to my left motor or my left motors, and then a right joystick to assign to my right motors. And then I could run this program and I could have basic driving control over the robot, just the drivetrain. The last value inside of there was a threshold value, so it would ignore low values from my joysticks of -10 to +10 here in this program. So that was a very rudimentary, just driving program in ROBOTC Graphical. Inside of Modkit Blocks, there's some good similarities. We have the when started command block, and then we have a while loop with a condition set to true. So that there again, that's an infinite loop. It's going to repeat forever. So it's going to repeat my joystick commands forever. So it's going to continuously set the values of my motors equal to the values from the joysticks. Okay, so the looping idea is the same across both languages. And then what's different is how we go about accomplishing that. Inside of Modkit, what we do is we use the set velocity command. So you can see left motor dot set velocity and right motor dot set velocity. Right? And then what we're doing, instead of hard coding a number like 50, 75, -25, whatever hard coded value, instead of doing that, what we are doing is we are accessing the values from the joysticks on the remote control. So there you can see controller 1, axis 3, position in percent, controller 1, axis 2, position in percent. So every time that this loop repeats, it sets the default velocity of the motors equal to the position values from my joysticks. All right, so it's setting the default velocity there. And then immediately after, we have to actually tell the motors, okay, now spin at that speed. And that's what the spin commands do. Left motor dot spin, right motor dot spin. They now spin at the new velocity, which was pulled from the controller. All right. And then if you do have a robot with an arm or a claw, um, we were able to add the arm control command inside of ROBOTC Graphical, where you could specify the motor that you wanted to control. You could specify the two buttons that you wanted to control that motor, one for positive motor speeds and one for negative motor speeds. And then you could choose the motor speed. So here, if I pressed BTN 6U, a motor power level of 50 was sent to my arm motor. If I pressed BTN 6D, -50 was sent to my arm motor. Inside of VEX Coding Studio uh, with Modkit, we implement arm control instead using a series of if-else statements. Our first if statement, we check if the up button that we want to use is being pressed, if it's dot pressing. If it is, we can spin the arm motor forward. Else, we check if the down button is pressing. If it is, we can spin the arm motor in reverse. And then else, meaning the up button and the bottom button, the up and the down button, neither one of those are pressed, then we can go ahead and we can stop the arm. All right, and this is very much how you would program basic arm control or basic claw control inside of standard ROBOTC as well. As you would check the values of the remote control buttons using an if-else conditional loop, and that's how you would do it inside of Modkit Blocks as well. All right. Just a friendly reminder, there is a really great resource at help.vexcodingstudio.com. It's a full listing of all of the commands inside of VEX Coding Studio for Modkit, VEX C++, and C++ Pro. A lot of great information inside of there if you're trying to figure out what a command does, or you're trying, you know what you want to do, but you need to find the correct syntax. That's really a very helpful place to look. Also, again, the STEM labs. Any of the programming STEM labs have instruction that show you how to create a program in VEX C++, but also Modkit Blocks. So regardless of whether you want to go through and you want to be a graphical programmer or you want to be a C++ programmer, whether you're new or experienced, you can find the instructions in order to support you. So definitely check those out, and then notice that it's usually inside of the play sections of the STEM labs that it supports both graphical and text-based programming just on different pages. So check out those different guides in there. It's a great way to learn going through those resources. All right. And then once again, thanks everyone for joining me for this webinar series. This is a lot of fun for me to run. I hope that the content of these webinars is helpful for you as you do adopt the new system and the new programming language. I'll leave the webinar open for just a little bit. If you have any questions, feel free to put those inside of the chat box. I'll do my best to answer those. You can always feel free to post additional questions later in YouTube or on the various VEX support channels. VEX has a Twitter link. They also have their support channels. Check those out. And then if you are interested in training from the Carnegie Mellon Robotics Academy, you can learn more about our V5 offerings at the link that we have here. It's cmu.edu/Robotics Academy. Okay. Question from Dan from, is button up and button down a preset name already assigned to particular buttons? Maybe I missed it. The other option stated button 6 up and down. Sure, that's a great question. So let me actually show you inside of VEX Coding Studio. So if you do want to use the remote, a very important step to remember is to add the controller to your robot config screen. Otherwise, as your function list on the left won't get populated with some of the bucks inside of there. And let's see, let's add a if else to my program. Now, don't download this program, it won't give you remote control. But this is just to show you how the fields are populated. Okay, so if I drag and drop, I'm under sensing, by the way, which is the purple section. You'll notice that there's controller button and there is controller axis. So whenever you want to reference one of the buttons, you drag and drop the controller in, and then there is a second drop down that allows you to choose between all of the different buttons on the remote controls. So we have button A, button B, down, L1, L2, left, R1, R2, right, up, down, X, Y. So that is how you specify the specific one in VEX Coding Studio. And as you would expect, there are labels on the physical remote that align to these. So there's labels A, B, X, Y, L1, L2, those kinds of things. So just look at your controller, see the label that's next to it or on it, and then you can choose the corresponding option inside of there. Okay, from Sean, can you have more than one program project open at a time in Coding Studio? So inside of the current version, you cannot. I believe that it is on their roadmap to be able to support multiple programs, multiple projects, but for right now, it is just one at a time. All right. Well, oh, here's another question. Is the set velocity percentage command based on predetermined max of the motor design and the internal coder readings? Yes, it is. So inside of VEX Coding Studio, that would be under settings, and I need to actually add a motor to be able to have that populated, same as with the controller. So under settings, you'll see that you can drag in the set velocity. And right now, the only option for that is percent. So that that you can do -100 to +100 for percentage of velocity. All right, from Alex, the tank controls are controlled like a tank. Yep. So at least if we mean the same things. So what we mean by tank control is usually the right joystick controls the right side of your robot's drivetrain. The left joystick controls the left side of your robot's drivetrain. That's to contrast it from arcade control, where pushing up on one joystick moves the whole robot forward, pushing down on that joystick moves the robot backward, pushing to the right turns the whole robot to the right, pushing to the left turns the whole robot to the left. This is a driver preference thing. Sometimes people also like to have a second joystick totally free for controlling another mechanism on the robot. But tank control typically what it means, how it's used is right joystick controls right side, left joystick controls left side. All right. Another question from Alex. What does set max torque motor function do to a motor? So that's actually another great command to use. Uh, that's actually a great command to use if you are using an arm or a claw. Uh, Setting the velocity of a motor is something that's very familiar to us. We're setting what we want the speed to be. But setting the max torque is new to the V5 system, and it allows us to control the strength of a motor. Um, so this is really helpful if you have a strong motor, but delicate components like small gears, small plastic gears. You can set the maximum torque to a certain percentage, and then your motors won't push too hard, even if they have more strength to try to. So imagine that you have a robot and you want it to carry an aluminum can without crushing it. Well, you could set the max torque, find the right value so that it would be able to pick it up, have the correct amount of friction without actually squishing it. Okay, from Sean. I may have missed it, but are there plans for future webinars? Thanks. So thanks for asking, Sean. So we are planning on doing our formal professional development training starting in February. So if you're a teacher or a coach and are looking for training, feel free to check that out. We are also planning on doing additional free webinars as the demand arises. So we've heard a little bit of demand around using the vision sensor, since that's new. We'd be happy to cover things like those inside of the future, get those on the schedule. So let us know what types of topics you'd like us to cover, and then we'll get out there and make sure to do so. That's something that we are committed to helping with the community. Okay, from Gonzalo. From what I saw, setting velocity, speed, and moving motor are now two separate commands. Am I right? Yes, you are correct. Inside of Modkit, uh, whenever you spin a motor, um, which is an action, uh, you will want to use spin, rotate to, rotate for, start rate to, start rotate for. All of those are options to start the motors. Uh, some of them have durations built into them, like the rotate to, rotate for, and start rotate to, and start rotate for. Many of them have durations, but none of them have speed built in. If you do not specify a speed, I believe it defaults at 50% for the entire program, but setting the velocity allows you to change the default for the entire program. Now, if you are using VEX C++, um, these rotate to, rotate for, start rotate to, and start rotate for commands, they are what are called overloaded functions, meaning that they can be used with or without speed. Overloaded means that you can have different amounts or different types of parameters for a command or for a function. And so in the C++ language, you can choose to use these commands and include speed in the one command, but Modkit, they are distinctly separate, at least if you're using the graphical mode. Okay, Dan, thanks for the positive feedback. I'm glad to hear that the webinars are helpful. Do please feel free to hit us up with any questions that you have, even if they're about IQ or the Cortex system. Those are all platforms that we proudly support and would happy to help you with. All right. Well, if any questions do come in later, do please feel free to hit us with those. I'm happy to check in and do my best to answer those. Have a great rest of your week and good luck as you do transition over to the V5 system.